So let's find the slope between 2 points which have x and y both being fractions. Specifically, let's find the slope of the line that passes through the points 5/9 12/5 and 22/9, 22/5. All right, now this gives students a little bit of trouble because it's a lot of fractions. So let's talk through this step one at a time. All right, to find the slope of any line, let's remind ourselves that we use the formula delta y over delta x. In other words, slope is a change in the rise direction divided by a change in the run direction, or the change in y divided by change in x. Another way to think of it is the formula y2 minus y1 over x2 minus x1, where x1, y1 is a point and x2, y2 is a point. That is, specifically, I have 2 points up here. The first point I'm going to denote by the subscript 1. So 5/9 is actually my x-coordinate of the first point. 12/5 is the y-coordinate of the first point. And 22/9 is the x-coordinate of my second point. 22/5 is my y-coordinate of the second point. To get the slope of a line through 2 points, we subtract the y values and then we subtract the x values. We have to be careful to make sure we subtract in the same order both times. So let's start by taking y sub 2 minus y sub 1. That means that in the numerator we have 22/5 minus 12/5, right? Y sub 2 minus y sub 1. And in the denominator now, I have the second guy, which is x sub 2 minus x sub 1. So we have 22/9 minus 5/9. Okay, so now let's combine like terms. In the numerator, because I have like denominators of 5, I can add my numerators or subtract my numerators. So 22 minus 12 is actually 10 over 5. And the denominator, down the bottom, I have common denominators of 9, and I can combine those two fractions by taking 22 minus 5, which is going to give me 17 over 9. So I have the fraction 10 over 5 divided by 17 over 9. Let me go one more step quickly. 10 divided by 5, notice I can reduce that fraction. 5 is equivalent to 5 times 1, and 10 is equivalent to 5 times 2. In other words, both 10 and 5 are divisible by 5, and so I can cancel the common factor of 5, leaving me in the numerator with 2 over 1 divided by 17/9. Okay, so far. So our slope is actually a complex fraction. Fractions within a fraction. Now, how do we simplify complex fractions? All right, well, one way I like to do it is I like to take this vertical division and turn it into a horizontal division. 2 over 1 divided by or over 17 over 9 is the same thing as 2 over 1 divided by 17 over 9. And the reason I do it that way is because we are familiar with dividing fractions when it's horizontally written. We have that little formula or that little saying, keep, change, flip. Have you heard that before? My students actually taught me this one. Keep, change, flip. We keep the first fraction. We change our symbol from division to multiplication, and then we flip or invert our second fraction. So to divide 2 fractions, we keep the first one, we change that middle symbol to multiplication, and we invert or take the multiplicative inverse of 17 over 9, which is 9 over 17. We flip it over. We finish by multiplying, and remember, when you multiply fractions, you multiply straight across. So we're going to take 2 times 9, and that's going to give us 18. And then we're going to take 1 times 17, and that's going to give us 17. This does not reduce any further, and that tells me that the slope of the line through the points 5/9, 12/5, and 22/9, 22/5 is simply 18 over 17. go up 18 units for every 17 we move horizontally.